Okay, in this video, I'm going to be working out for you the exam review problems, practice problems for Chapter 1. So I have the sheet here that I gave you. On number 1, it wants the most specific subset of real numbers to which -8 belongs. So if you look on page 2 in your textbook, you'll see this little graphic that we had gone over in class. It's a Venn diagram for the real numbers. Real numbers include two sections, rational numbers and irrational numbers. Irrational numbers are ones that can't be written as a fraction or a repeating decimal. They include square roots that can't be simplified, like root 5, pi, and the 2.7129, and the little dots there showing it's a fraction, a decimal that just keeps going on and on. Those kinds of things can't be written as fractions. Rational numbers are numbers that can be written as fractions. That would include decimal numbers like the 0.65 down there. You could rewrite that as a fraction, like it's 65 over 100, which could reduce to something else. And then it includes all of the not fraction numbers, like the normal numbers that we think of. So in that, the most general set are the ones that include the negative numbers, along with 0 and the positive numbers. That would be these guys right here. That's a beautiful circle. Those are the integers. So if you're given a negative number that's not a fraction or a decimal, the most specific set that it's in is the integers, which is our answer. It's going to be our answer for number 1. But if they give you another number on the exam, if they give you 0, the most specific set that 0 can go into are the whole numbers. And if they give you a number that's positive, not a fraction or decimal, then it can go in the very most specific set, which is the natural numbers. They're also called counting numbers. But for our problem on number 1, they gave us a negative number that's not a fraction or a decimal, so the most specific set it can go in is the integers, and that would be your answer for number 1. If you want more practice, you can go to pages 2, where the diagram is, and then on page 3, example 1 has a few more of them. All right, then we have a problem where we're classifying a polynomial. First of all, they want us to state its degree. Degree has to do with the highest exponent. The highest exponent that you see in any single term. You don't add together exponents from separate terms. So for instance, -3x to the 4th is one term, 9x squared is the second term. We wouldn't add those two exponents. We did add some exponents when we were doing these sorts of problems in class, but that's when you had like another letter in the same term. Then you would add the exponents for the two letters in the same term. When you only have one letter per term, like just x, you only look at what the highest exponent is. That's the degree of the whole polynomial. So our degree here is our highest exponent of 4. That would be our answer for little letter A. Little letter B wants us to classify the polynomial according to the number of terms. So terms are separated by plus or minus signs. We have 2 terms added together here. So we've got 2 terms. That's not the answer, though. There are actual words for polynomials that have a certain number of terms. Those words end in nomial, and you get a prefix based on the number of terms. If you have 2 terms, it's binomial. If you had 1 term, it would be monomial. 3 terms would be trinomial. So this is 2 terms, it's binomial. And that's the answer to little letter B. The instructions for how to do that were on page 13. There's a couple examples on that page. They were a little bit more complicated actually than the one I gave you, so I don't know if they'll be confusing to look at or not. Numbers 3 and 4 are both order of operations problems. And I know that the mnemonic you guys have learned for order of operations looks like this, where you have parentheses. That's what you do first, then exponents, then multiplication, then division, then addition, then subtraction. It's a little bit misleading. You do want to do things inside the parentheses first. If there's no parentheses, you do exponents. But then this is where it's confusing. Multiplication doesn't necessarily come before division. Multiplication and division should happen at the same time, and you do those as they appear in the problem from left to right. Same with addition and subtraction. Addition doesn't have priority over subtraction. Both of those should happen at the same time from left to right in the problem. So you're going to see that as I work out these problems here. So I look for parentheses first, and even though there's not exactly parentheses, these absolute value signs you can treat like a parentheses. You should do that part, what's inside the absolute value sign first, just like you would if it were parentheses. So inside this absolute value, I have 4 minus 8, that would come out to a negative 4, and then I do the absolute value function on it, and I should come out with a positive 4. That's going to end up being multiplied by the 2 there. And then I have everything else written out. Also, at the beginning of the problem, I have an exponent. That's what should come second. So I can go ahead and do that now. Since there wasn't a parentheses anywhere near it, I can go ahead and do it on the same step. 6 squared is 36. All right, here's where this multiplication and division at the same time from left to right comes into play. I'll put a dot there, but I'll put a multiplication sign. I need to do all of this multiplication and division at the same time from left to right, or not even, maybe at the same time is a bad way to say it. You need to do them in order from left to right. Don't do the multiplication before the division necessarily. So reading the problem from left to right, that's this way. The first thing I get to is this division symbol. That's what I should do first. So the first thing I should do is 36 divided by 3, and I get a 12. And then I'll still have the rest of the line here, just breaking it down into steps for you guys. The next multiplication or division that I get to is this 12 times 4. That's what should go next. 12 times 4 is 48. And then I'll keep the next part of the line the same. Then I skip over the subtraction sign because I am still on the multiplication and division step. The next multiplication I get to is 2 times 4, and that's what I should do next. And I'll have an 8 in the place of the 2 times 4. Then my last step is to do any addition or subtraction that I see in order from left to right. Obviously, there's only the subtraction 40 minus 8, and you'll get a 40. And there we go. So we've got another problem to practice our order of operations. It's a little bit more complicated than the last one, but if we just take it step by step, we should be all right. The first thing we want to look at is parentheses, and that's what is making this problem more complicated, is that we have parentheses inside of parentheses inside of parentheses. And when you have parentheses inside of other parentheses, they'll use normal looking parentheses as the innermost layer, which is where you should start first. Brackets are the second layer. They put those around regular parentheses, and then if they need other parentheses, that's when they use this little guy. They call it a brace. So when you have multiple parentheses, you want to go to the innermost kind of parentheses first, which are the normal looking parentheses if they're there. So I have all this. I need to simplify what's inside of these 2 innermost looking parentheses. I won't even worry about this one right now. We need to do that later. I'll just take it away. Let's look at this parentheses that's inside the brackets. I have 5 minus 2 squared. And so if I'm just worried about this part, I should do the exponent before I do the subtraction. So 2 squared is a 4. And then I'll do 5 minus 4. 5 minus 4 is a 1. So that whole parenthesis simplifies to a 1. And then I'll write out the rest of the line that I still have. Okay. Then I have a brace written here, but it's now on the same level as this parentheses. So I can do each of these parentheses now and simplify what's inside them. So 4 minus 1 simplifies to a 3. And then the multiply. It needs to be multiplied by this next parentheses because there's nothing between the parentheses. If there's no plus or minus sign, it means it's an understood multiplication. So that's why I have that multiplication symbol after the 3. Multiply by what's inside the second parentheses. Negative 3 minus 9 would make a negative 12. So that's a negative 12. I'll put it in parentheses so I just remember that that negative does not mean that I subtract it from the 3. I need to multiply 3 by a negative 12. And then I have the rest of the line still like it was, divided by 9 minus 3. Okay. Next, I can work in, we're still kind of trying to do the parentheses step, and I do have one more parentheses here. These braces are my last set of parentheses, so I need to do what's inside them before I worry about that 2. That 2 on the outside of the parentheses has to be left to last, since I'm supposed to work with parentheses first. So inside the parentheses, I've got a few different things going on. I'm supposed to multiply and divide and subtract. And according to my order of operations, I need to do the multiplication and division before the subtraction and do them as they appear in the problem going from left to right. So that means the first thing I get to will be the 3 times negative 12. So 3 times negative 12 makes a negative 36. And then I'll keep the rest of the line like it was. The next thing I get to in the parentheses is the 36 divided by 9, or actually negative 36 divided by 9. So negative 36 divided by 9 is negative 4. And then I keep the negative 3 there, minus 3 there, rather. And now I'm ready to do the subtraction since I've done the multiplication and division. Negative 4 times negative 3 is negative 7. That simplifies that parentheses all the way down, so I'm ready to multiply it by the term on the outside of the parentheses. So I'm finally ready to multiply by the 2, and I get negative 14. That's my answer for number 4. If you would like more practice on these order of operation problems, these are actually a little bit more complicated than the example, but the only example they have for it that I could find is on page 8, example number 2. And then if you look in the lesson, the exercises for that lesson, I'm sure you could find some practice problems, hopefully an odd one that you can look up an answer for. All right, the next 2 problems are similar to each other, where they give you an expression with letters and numbers, and then they tell you what the letters are equal to, the numbers that they're equal to, and they want you to simplify or evaluate. That you'll come up with a single number for your answer, just like we did on the previous problems. So what we need to do is substitute what A equals and what B equals into our expression here. All right, so A equals 3. So I substitute in 3 squared, and then 3 times 3. B is equal to negative 2, and I only have that one place to put that in. Okay, and then it kind of just becomes an order of operations problem like we were doing above. First thing we need to do is simplify inside the parentheses, and then we can also simplify inside the absolute value sign, since those are kind of like parentheses as well. So inside the first parentheses, I need to do the exponent and the multiplication before I can combine and do the addition and subtraction. So 3 squared makes a 9. Then I've got 3 times negative 2. That makes a negative 18. But then with that minus sign in the front, a minus negative 18 essentially becomes a plus 18. So that's what I'll put there for the middle term. And then I still have the plus 2 from the end. And then inside the absolute value sign, I've got negative 3 times 3, make a negative 9. Okay, then I can finish simplifying inside the parentheses and absolute value. In the first parentheses, 9 plus 18 plus 2 make 29. And then the absolute value of negative 9 is a positive 9. I still have the minus sign that was in front of the absolute value. That's why that's there. All right, 5 times 29 is 145 minus 9, because we should do the multiplication before we do the subtraction. And then 145 minus 9 is 136. The next problem is similar to that, but we have 3 letters. So if P equals 2, we'll substitute 2 in the place of P. Y is equal to 3. And then M is equal to -4. Then we should simplify each of these terms, do the exponents and multiplication before we do the addition and subtraction. 2 to the 3rd power is 2 times 2 times 2, that's 8. And then here, we have to do the exponent before we do the multiplication. According to our order of operations, or PEMDAS, you do exponent before multiplication. That means that you square that second 3. Square the second 3 before you multiply it by the first 3. So you'll end up with that first 3 is still there, times 3 squared, which is 9. That's what we're going to end up with. And then -2 times -4 makes a -8 on the last term. That middle term here, 3 times 9, I need to do that multiplication before I do the subtraction that's around it. 3 times 9 is 27. And then I have something wrong. Oh, the -2 times -4, I said was -8, but it's not. It's +8. I'm sure you guys caught that. So that should be a +8 at the end. All right, then I have 8 minus 27 plus 8, and that comes out to -11. If you need more help on problems like 5 and 6, you can look on page 9. Example 4 goes through similar problems. All right, 7 and 8 are sort of similar problems to each other. You have to simplify an expression that has letters and numbers, and your answer is not going to be a single number since we don't have anything to substitute in. You just want to simplify by adding like terms. That's all it is on number 7, adding like terms. So I do have parentheses. I'd like to get rid of those parentheses before I do any addition and subtraction. In the first parentheses, there's nothing in front of the parentheses here that would affect anything inside the parentheses, so I can just bring all these terms out with no parentheses around them and they'll be unchanged. The second parentheses, though, has a minus sign in the front of it. We're subtracting everything in the second parentheses, so I actually need to distribute that minus sign to each of the terms inside the parentheses, first term included. So when I write them here on the line below, you'll see that I should have a minus 2ab squared minus a squared b squared and minus 5a squared b. All 3 of them get the minus sign. If any of them had a minus sign in front, it would multiply by the minus sign on the outside of the parentheses and become a plus sign. Now we want to combine like terms. To combine like terms, you want to find 2 terms that have exactly the same 2 letters with exactly the same exponents. So for instance, a squared b is not the same as ab squared because the squared is in the wrong place. This 3a squared b, I'm going to look at the end and find another a squared b. That's what I can combine it with. When you're adding and subtracting like terms, this step here, you do not change the exponents. You only add or subtract the coefficients, the numbers in front of the letters. So 3 minus 5 make a -2, and I still have the a squared b like it was. The next term I see is ab squared, so I'm going to look for another ab squared to combine it with. I have one more, and I combine them by adding their exponents. -4 and -2 make a -6. Then I have a squared b, so I find another a squared b to combine it with by adding their exponents. This has a plus, or adding their coefficients, I'm sorry. That one has a +1 coefficient, and then this is a -1 coefficient, which actually come out to 0. So if you come out to 0 when you're adding, that term goes away and does not show up in the answer. This is our answer. Number 8 has an extra step before we can combine like terms, since they have some sort of term outside the parentheses, we have to distribute first to get rid of the parentheses. So 4x times 3x makes a 12x squared. Don't forget to multiply the letters. X times x is x squared. 4x times 5y is 20xy. Two different letters. You don't change the exponents, they just both show up. Then when I'm distributing in the second parentheses, I'm going to treat that 2y as a negative 2y so that I'll remember to distribute the negative sign to both these terms. So negative 2y times 10x make a negative 20xy. If you have multiple letters, put them in alphabetical order. And then negative 2y times a negative 3y make a negative 6, negative 2 times negative 3, and then y times y is y squared. Once you've distributed and gotten rid of the parentheses, now you want to look and see if there's any like terms you can combine. I only have one term that's x squared, so it's going to stay like it is. Then I have two different terms that have x times y. I combine them by adding their coefficients. Positive 20 with a negative 20 makes a 0, so that term is going to go away. I won't have an xy term in my answer. And then the negative 6xy, or negative 6y squared, doesn't have anything else to combine with, so it just comes down. And that's our answer. If you need more help with these sorts of problems, combining like terms, you can look on page 14 and example 4. All right, moving on to number 9. This one is a little bit trickier. A lot more of you had problems with it. When you have exponents outside of the parentheses, it's a little bit tricky, especially when you're combining it with letters inside that have their own little exponents. So the way that you do that, if you have an exponent outside the parentheses, an exponent of a letter inside the parentheses, you combine them by multiplying them together to make a new exponent for that letter. All right, so that x is going to get a new exponent of 6. But also, not only are the letters going to end up with new exponents, but any number that you see needs to get this exponent as well. It's a little bit different. You don't multiply it by that exponent, you just give it that exponent. So the 6 is going to get an exponent of 2. And then the x is going to have a new exponent. It's going to be 3 times 2, which is 6. The y had an exponent of negative 1 that we're going to multiply by the 2 to get a negative 2. And the z had an exponent of 2 multiplied by the 2 to get a 4. In the denominator, this first little parentheses here has an exponent of 2, so everything inside it gets an exponent of 2. If you don't see any exponents, then it's easy. You just give everything inside an exponent of 2. It's still kind of like you're multiplying the exponents because they have understood 1 exponents, and 1 times 2 is 2. And then this second parentheses does not have an exponent, so I can just multiply everything else in the denominator by those things that are inside that parentheses. All right, so I'm just going to simplify the numerator and denominator on this next step. The only thing I'm going to do in the numerator right now is take that 6 squared and make it 36. And then I don't have any letters that are in two different places in the numerator that I can combine, so I'm just going to leave them like they are for now. When I'm simplifying the denominator, I've got two different numbers, 3 squared, which is 9, times a 4. 9 times 4 is 36, so that's the number that's going to be in the denominator. Then I've got one x term, so I'll just keep that x squared like it is. I have two different y terms. When you're multiplying two different y or two different letters together that are on the same level like that, you can make them into one by adding their exponents. So this y without an exponent is really an understood 1 exponent. So if I add that to the y squared exponent, I'll get y to the 3rd power. We already multiplied that 4 to get the 36, and then the only term that's left is the z. There's nothing else in the denominator, no other z's to combine it with, so it's just a z. Our last step is it's sort of like we're combining like terms. We don't want to have two different numbers. We just have one number, or we want to simplify the numbers into the simplest fraction that they can be in, if that's the case. We don't want two x terms. We don't want two y terms or two z terms. We want each letter to only show up in one place, either the numerator or denominator. And wherever they end up, they need to have a positive exponent. Okay, so first of all, the 36 divided by 36 cancels down to 1. So I'm not going to have a number in my answer because 1 can be understood. Next, to combine the x's together, you need to move one of them from the numerator to the denominator. Whichever one you move, its exponent is going to become negative, and I want the overall effect to be positive. So for instance, I could either move the x squared up, and it becomes x to the negative 2, and then I combine it with the positive 6, and I would get an exponent of positive 4. If I had moved the x to the 4th down, it would be x to the negative 6 plus the 2 exponent that was there, and I would get x to the negative 4. But I don't want a negative exponent, so that's not the right. That's why I am going to choose to move the x squared up instead of moving the x to the 6th down. So now I just have one x term in the numerator, and it's going to have a positive 4 exponent. So I got rid of these guys. For my y terms, I can already see in the numerator I've got a negative term, and I don't want to move something up and make it even more negative. So I'm going to move this negative 2 down, and it's going to become a positive 2. I'm going to add that with the 3 exponent that's already there in the denominator and get a y to the 5th, and it needs to be down in the denominator because I moved the y negative 2 down. And then to simplify the z's into one term, since the exponent in the numerator is bigger, I'm going to take the denominator and move it up. It's going to be z to the negative 1, and then I add those together by or multiply them, sorry, by adding their exponents. 4 plus negative 1 makes a positive 3. And that's going to be my answer. Sorry that the y is off center. If you need more help with those sorts of problems, you can look on pages 12 through 13. Example 1 has some more problems like that. All right. On our next problem, we are solving for a letter. In this case, we're solving for z. And we're actually going to come up with a number for our answer. It's sort of like problem 7 and 8 on the previous page, but we can actually come up with an answer since we've got an equal sign in this problem. You want to start off like we did on 7 and 8. Get rid of the parentheses if you can. In this case, I get rid of the parentheses by distributing. So 2 times z and then 2 times 3. The minus 3z stays there for now. And then on the other side, get rid of the parentheses. We do 7 times z and 7 times 1. And then I still have the plus 15. Then I'm going to combine like terms on each side separately. So on the left side, I've got a negative 2, a 2z minus a 3z will make a negative z. And then the plus 6 doesn't have another number to combine with, so it stays. On the right side, I only have one z term, so I'll bring it down. And then I have two numbers that can combine together, plus 7, positive 7, and plus 15 make a plus 22. Now I want to solve for z. So that means I need the z terms to be on one side. We usually take them over to the left side, and the non-z terms to go over to the other side, the right side. So I'm going to subtract 7z from both sides, and then that'll get the z's over to the left. And then I need the 6 to move over to the right, so I'm going to subtract 6 from both sides. So I'm going to write the result over here to the right. Negative z minus 7z makes a negative 8z, and 22 minus 6 makes 16. Then I can finish solving for z by dividing by the coefficient, negative 8, and I'm going to get a negative 2. That's what z equals. You can get more practice with problems like that on page 19 if you look at example 2. All right, number 11 has one of our word problems. We actually had problems like this in 2 different chapters. It was first introduced in chapter 1 though, so that's why it's on this review sheet. There's an example very much like this practice problem on page 25. It's example number 3. So in order to do these problems, I would first notice that we're investing $10,000 into 2 different accounts. That's the total amount we're investing. So if I pick out X and Y to represent the amount that's in each of the 2 accounts, X in the first account, Y in the second account, it has to add up to make 10,000. That's going to be, we're going to use that in a second. So the way that we would solve these interest order problems is to make a table where the numbers for one of the account, in this case we have a 5% yield and a 6% yield. So we'll just label our accounts with the interest rates. And then in the rest of the table, you want a column that represents the principal. That's the amount that's invested in each account. And that's where this X and Y equaling 10,000 is going to come in. We'll call the amount that we put in the 5% X. And we could call the amount that we put in 6% Y, but we only want one letter eventually in an equation that we're going to be able to write in order to solve for that one letter. If you have 2 letters in one equation, you can't solve for it. So instead of putting a Y there, I'm going to take the fact that I know X plus Y has to equal 10,000 and solve for Y. Y would be 10,000 minus whatever X is. And that's what I'm going to put as the principal amount for the 6% account instead of choosing a second letter Y. Then we want the rate for each account in the second column. That's the 5% and 6%, but it needs to be written as a decimal. You write it as a decimal by dividing the percent by 100, moving the decimal over 2 places. Then we always had a column for time. That's the number of years that you're invested. All the problems that you're having in this class, at least so far, is amount earned in 1 year. So our time has always been 1 year. And then the last column is representing the interest that's earned. And they talk about how much interest is earned in the problem. That's not what's going to go in our table, though. In the table that we write out for these word problems, our last column always comes as a product of the columns before it. So you take, in this case, the 3 columns before it, and you multiply them together and get some little, it's not a number, it's just some little function. In this case, we got x times 0.5 times 1. So we have 0.05 times x. On the second column, you'll have 0.06 times that principal of 10,000 minus x. Okay, now we can look in the problem to the fact that our total interest earned is going to be 575. That means these 2 guys together are going to earn $575 in a year. So we're going to write an equation that says that the interest from the first account plus the interest that we figured for the second account, 10,000, comes out to the amount that they told us was earned in the problem, 575. And this is our final equation that we need to solve for one of the 2 amounts. And then we can subtract from 10,000 to get the other amount. So to start solving, I'm going to get rid of that parentheses by distributing the 0.06 to both of the things inside the parentheses. So 0.06 times 10,000 is 600. 600. And then 0.06 times negative x is negative 0.06x. I'm trying to solve for x. My next step is to combine like terms and to move, make sure the x terms are on the left side, non-x terms go over to the right side. So I need to subtract 600 from both sides. And I also need to combine these 2 x terms together. So 0.05x minus 0.06x is negative 0.01x. And then over on the right side, 575 minus 600 is negative 25. Then I finished solving for x by dividing both sides by negative 0.01. And you could put that in your calculator, you'll get 2,500. So again, in our table, X was representing the principal invested in the 5% account. So I want to label it that way when I'm writing out my answer. This is a number of dollars that's invested at 5%. I also need to tell, they want to know how much was invested in each account, not just one of the accounts. So I know that the second account, the amount invested is 10,000 minus X. So if I take 10,000 and subtract X, that means the second account has $7,500 in it, and that was at the 6%. So we want both numbers, and we want to properly label them so we know which number goes with which account. And again, if you need more help on that sort of problem, page 25, example 3 is just like this with different numbers. So you can see them work it out again. Then in chapter 1, toward the end of the chapter, we started going over inequalities and solving inequalities. So here I have an inequality to solve. I'll start working it out very much like the problem above where I had to solve for z. It's very similar to that. So the first thing I need to do is get rid of all the parentheses by distributing. So in the first parentheses, I'll have 5 times s, and then 5 times negative 3. Keep that little inequality sign looking exactly like it is, unless you have to divide by a negative. I'm sure that we'll see that in one of our examples. On the right side, we have 3 times s plus 3 times 5. And then for the last parentheses, 2 times s, and then 2 times negative 1. Okay, now we want to, I'm going to simplify each side separately before I move things from one side to the other. So on the left side, I have 2 s terms that can combine to make 9s. Nothing to combine with the negative 15. On the right side, I have 2 s terms. They can combine to make 5s, and 5 and s, very similar. And then 2 numbers, 15 and negative 2, can combine to make a positive 13. Now I want to move all the things with letters, in this case s, over to the left side, numbers over to the right side. So I'm going to be subtracting 5s from both sides, and then adding 15 to both sides. On the left side, that's going to give me a 4s, 9 minus 5. And on the right side, I'm going to have an not an 8, that's wrong, and a 28. And then last step is to divide by the coefficient of s. That would be dividing both sides by 4. And when you are dividing with an inequality, that's where your inequality matters. It could change direction, but if you're dividing by a positive number, it doesn't change the direction, so it's going to stay less than. And then 28 divided by 4 is a 7. So that's my simplified answer. That's the solved answer. S is less than or equal to 7. Not only might you have to solve for inequalities, but you also might have to graph them. So that's what we get to practice here. We're going to both solve and then graph it. I'm going to do this over to the side since there's not a lot of room. So I've got 3 parentheses, x minus 2. I'm just copying it out. I'm not changing it, at least not on purpose. If I change it, you just let me know. All right. So I've got 3 parentheses x minus 2 greater than fx, 5 times x plus 6. All right. Now we want to start to simplify it, try to solve for x. So I've got parentheses. I want to get rid of that by distributing the 3. Sorry, not like that. So I have 3 times x and then 3 times negative 2. And then I'm going to get the x terms over to the left side, so I have to subtract 5x from both sides, and then get the numbers over to the right side, or I'm sorry, the right side, so I'm going to have to add 6 to both sides. That's going to give me a negative 2x on the left side and a 12. 6 plus 6 makes 12 on the right side. Finish solving for x by dividing by negative 2. And here's the important part. If you're dividing by a negative, the direction of your inequality flips. If you had an or equal to sign that I just tried to write there, it doesn't get added or taken away. It stays there or stays not being there, whatever the case may be. It's just the direction of your inequality that changes. So instead of having a greater than, now I have a less than. And then 12 divided by negative 2 is a negative 6. So that's the solve part. That's my solution. And then now they want me to graph it. So first of all, I need to find the number, negative 6 here. And then I need a circle on it. The circle will be filled in if there's an or equal to sign. It will be open if there's not. I do not have an or equal to sign, so on the negative 6, I'm going to have an open circle. And I'm going to draw mine above the line so it's clear what direction I'm about to draw this arrow. The direction of the arrow should match the direction of your inequality here. A less than is kind of pointing to the right, so I'm going to draw my arrow, my line, going off to the right. Like that with a little arrow at the end. And that would be graphing the solution set. If you need more help on solving inequalities, look on page 30 at examples 1 and 2. All right, we do have one more problem with inequalities, and it's a compound inequality problem because we have two different inequalities. And they're either going to be a conjunction or a disjunction. So the example that I pointed you to is on page 35. On page 34, though, it goes over a little bit of a review of what these symbols mean. We'll do a quick review right here. So that downward kind of arrow, upside, or it's a right side up V. This is a disjunction. And it could also be represented with the word or. They could put the word or between two inequalities. It means the same thing. And these guys, you want a union. Basically means your answer needs to graph both of the solutions that you get from the inequalities. You graph both of them. If you have an upside down V, or a little TP, that's what they call a conjunction. They also can indicate you have a conjunction by using the word and what they want is the intersection. That's what they call it on page 34. The way that I described it to you is the overlap. So instead of graphing all of both of the inequalities, you only graph in your solution the part where the two overlap, the part of the graph that includes both of them. So this problem wants a disjunction. We need to solve each inequality and then just graph both of them. Okay. All right, so the first thing I need to do is solve each of them for x. So I'm going to do that right in the space I have below each one. I will put the x terms over on the right side. That means I need to add x to both sides on this first one. Non-x terms go on the right side. I think I misspoke, but I'm doing it right. So I subtract 8 from both sides. So on the left side, I've got a 4x. And on the right side, 12 minus 8 makes 4. And then I divide both of those by 4, and I get x is greater than 1. Okay, then I move on to the other one and solve it separately. I'll erase this little line that's in my way. And then I'll be moving the x terms to the left, so I'll add 2x to both sides. And move the 7 over to the right, subtract 7 from both sides. On the left side, negative 5 plus 2 will make a negative 3x. On the right side, 16 minus 7 makes a 9. Then I divide by 3, negative 3 actually, which is important because that means the direction of my inequality is going to flip. It'll be a less than now instead of a greater than. 9 divided by negative 3 makes a negative 3. And now, so that's the solve part. I would need to circle those as my answer. And then for the graph part, I want to go to the number line and graph it. So for the x is greater than 1, I find the 1, and I use an open circle. I'm going to graph it below the line and the numbers so you can see where my arrows are going. And it says x is greater than 1. You can see how the greater than symbol, it looks like an arrow pointing to the right, and that's how my solution needs to look. Arrow going to the right off of that open circle. To graph x is less than -3, I find the -3 and draw an open circle because, again, there's no or equal to sign. It's x is less than 3. That less than sign looks like an arrow going off to the left, so I draw an arrow to the left. And again, since I'm doing a disjunction, I want both of those graphs to be in my answer. If you need more practice with conjunctions and disjunctions, they're in example 3 on page 35. The last two problems involve the absolute value sign in an equation or in an inequality. If it's in an equation, like on number 15, what you need to do is take this absolute value equation and rewrite it as two separate equations. Both of those equations are going to get what's inside the absolute value. It's unchanged, so it should be 2x plus 3, just like it was in both of the equations that we're writing. It's the left side of the equation that becomes different between the two. One of them gets the 11, just like it was in the original. So one of your equations looks just like the original, except without the absolute value symbol. On the other equation, instead of a positive 11, you're going to turn the right side into a -11. Again, what's inside the absolute value sign does not change. The most common mistake I saw with you guys when we were doing these problems in chapter 1 is you would change that plus sign. Either change it in both of the equations, or only one of the equations it would be a minus. It shouldn't change at all. It should be the same in both. It's the right side, the thing that was outside the absolute value, that's going to be different only in one of the equations. Then we take each of these equations and solve for x. So I need to subtract 3 from both sides, divide by 2, and I get x equals 4. That's one of my solutions. On the other one, again, start by subtracting 3 from both sides, but this time the right side will become a -14. And then divide by 2, and you get -7. Both of these are your answer. There was one last step on these absolute value equations in particular where you would want to check your answers. So you would go back and plug it in, plug each one in, and make sure that what you got out of it, 2 times 4 is 8 plus 3 is 11, absolute value of 11 is 11. And then if we plug -7 in, it's inside the absolute value. 2 times -7 is -14 plus 3. -14 plus 3 is -11, but it's inside the absolute value sign, so the absolute value of -11 is positive 11, and that does equal 11, and both of those are true. Though, just a little shortcut, unless there's like an x outside the absolute value somewhere, probably both of them are going to be true. It was when there was an x on the right side of the equation, not inside the absolute value, that you would end up with a solution that was what they call extraneous. It did not actually work. There's more absolute value equation examples on page 39, examples 2 and 3. And then the very last section of chapter 1 was absolute value inequalities. For this one, you could do it one of two ways. This one's like example 2 on the bottom of page 45 and 46. Because it's a less than sign, you can actually write it as one big inequality that has 3 pieces. The outside pieces are going to be whatever this number is over here. In this case, it's a 3, the positive and negative version. So, at the beginning, make it a negative. At the end, it's positive. And then in the middle, you're going to have whatever was in the absolute value symbol is just going to come out exactly how it looked, but without the absolute value symbol now. That's the way they do it on example 2. And then solve for x. It kind of is like a three-sided equation though. So when I'm solving for x, like the first thing I need to do is add 5 to get rid of that negative 5. I need to do that to all three sections here, not just to the very right side. So on the left first piece, negative 3 plus 5 makes a positive 2. And at the end, positive 3 plus 5 makes an 8. And then I need to get rid of this fraction. And I can do that by multiplying by the reciprocal of that fraction. That'll cancel it out. But again, I need to do that to every single piece, all three places. So in the first place, 3 over 2 times 2 makes a 3. In the middle, these fractions have canceled each other out, and I just have an x. And then at the end, 8 times 3 over 2 makes a 12. And that would be your answer. I told a couple of you a different way, and it still does work. It's sort of like what they did on example 3, which is on page 46. You can write two different inequalities, sort of like we did above for the equation, where you take out what's inside the absolute value exactly like it is. Don't change the sign. It's going to bug me. One of the equations is going to look exactly the same as the original, but without the absolute value sign. The other one, you're going to change the number on the right side to a negative, or if it's a negative, you change it to a positive. You change its sign. But also, since this is an inequality problem, you're also going to change the direction of the inequality. So I'm going to have a greater than on this second equation instead of a less than. And then you could solve each of them separately. I'm going to do this kind of fast since this is just the alternate method. Add 5 to both sides and then multiply by both sides by 3 over 2. And you'll get x is less than or equal to 12. On the other equation, add 5 to both sides and then multiply both sides by 3 over 2 and you'll get 3. And this is sort of your answer. That's just not the best way to write it. Since x is greater than 3 and less than 12, that means it's between 3 and 12. It's greater than a small number and less than a big number. So it should be written, if you imagine taking this second one here and just totally flipping its direction, mirror image, the 3 would go over on the left, the x would go over on the right, and the direction of the inequality would flip. We're just making a mirror image. Then you could see how that can kind of go in the front of this, and the x's line up, and you end up with an answer that looks like the answer that we got over with our other method. So either one of those are fine, but if you do this second method, it still needs to be written. Your answer still needs to be written like that. All right, that's chapter 1, exam review problems.